In this lesson, we will cover Unit 6, Section 6.4, Slope-Intercept form of the equation for a linear function. In this lesson, you will learn how to relate the graph of a linear function to an equation in slope-intercept form. You will then generalize and explain strategies for graphing a linear relation in slope-intercept form, and graph a linear relation given slope-intercept form. So, linear functions. In Chapter 5, a linear function was described in different ways. We described it using words, ordered pairs, arrow diagrams, table of values, and we also described it using a graph. The linear function below represents the cost of a car rental. This graph can be described and represented by the equation C equals 0.20d plus 60. The number 0.20 is the rate of change, or as we represented in the last lesson, rate of change is the same as slope of the graph. This rate of change is the cost in dollars for each kilometer driven. The number 60 is the vertical intercept of the graph. This is the cost in dollars that is independent of the distance driven. It is the initial cost for renting the car. So as we can see from this equation, the number with the variable, so the coefficient with the variable, represents the rate of change or the slope. And the constant term is the vertical intercept. This is going to come in handy when we look at the slope-intercept form. So any linear function can be described in slope-intercept form. The equation of a linear function can be written in the form y equals mx plus b, where m represents the slope of the line and b is its y-intercept. So as we're talking about the previous example where we have 0.20d, that represents the slope of the line. So we could find that using rise over run, or you could pick 2 points on that line and use the slope formula to do that. And the 60 is where the graph would intercept the vertical intercept, and it represents b. So it does not matter what numbers you have for your slope or your y-intercept. They can be represented in slope-intercept form using y equals mx plus b. So if a question said to you, write the equation of a line using slope-intercept form that has a slope of 3 and a y-intercept of -5, then you would say y equals 3x subtract 5 as seen below. This equation of a linear function can be written in slope-intercept form when just the slope and y-intercept is given. So this is the best case scenario when you are asked this question, because everything you need is actually already given to you. So for an example, write the equation for the function that has a slope of -1/2 and a y-intercept of 7. So the slope is given to you, the y-intercept is given. There is nothing that you need to algebraically solve for. You will just substitute those values for slope and for y-intercept into the equation, which will result in y equals -1/2 x plus 7. Nothing required to do here, just plain old substitution, which will not always be the case. Next, we have the equation of a linear function can be written in slope-intercept form when given just a graph. So if we look at the graph that is given here, you will choose 2 points on the line. You will find the rise and the run, where the rise is 2 and the run is 1. So 2 divided by 1 results in a slope of 2. We will need to also find the y-intercept, and that is a point where the graph will cross the y-axis, and in this case the y-intercept is 0 and -3. Now we will start off with y equals mx plus b, where 2 is the slope, which will be substituted in for m, and our y-intercept is -3, so that will go in for our b value. What you can do there, since it is an ordered pair of 0 and -3, you put 0 in for your x, -3 for your y, and once you solve the equation for b, you will quickly see that b is -3. When you want to graph slope-intercept form, and are given a function similar to y equals -3/4 x plus 2, you will start off with the y-intercept. The y-intercept crosses the y-axis at +2, as can be seen in the equation. And then from there, you will go with your rise and your run of the slope. The rise in this case will be -3, and the run will be 4. So you will have a rise, you will go down 3 units, and you will go to the right 4. You will continue this process until you want to stop. And if you want to find the graph that is above in the positive y values, you will just switch your method. You will go up 3 and to the left 4. So in summary, the equation of a linear function can be written in slope-intercept form y equals mx plus b. M represents the slope and y is its y-intercept. Slope-intercept form can be written when given slope and the y-intercept, 2 points where you will first need to find the slope and use one of those points to help find b. Or you could be given the graph. When graphing a function in slope-intercept form, start with plotting the y-intercept, then use the slope in terms of rise and run.